Hello, chemistry enthusiasts. Once again, this is Monfort Kempaf here, bringing you part 3 of this series, the mole concept. And today we'll be focusing on mole calculations, right? The previous two videos we focused on the theory part. Now we're going to focus on applying those theories in calculations. All right, so let's get into it. So question 1, we have how many moles of magnesium chloride are present in 38.2 grams of magnesium chloride. So what is important to note is, one, was the question asking you, and two, what are you given? So the question wants to know moles, and you're given a mass which is 38.2 grams, and also you're given atomic values, and these atomic values is to calculate the molar mass of that compound. So if we're given molar mass and the mass, then we know our formula we have to use to find moles, which is mass equals, or sorry, moles equals mass divided by molar mass. So let's calculate the molar mass of magnesium chloride. So we have the atomic values given to us. All right, a key thing to note is to use our units. So magnesium is 24.3 grams per mole. All right, we use our units to help us to know what we are calculating and to have the right units at the end of our calculations. So it is 24.3 grams per mole times the amount of atom present in that compound, which is 1, right? Plus chlorine, which is 35.5 grams per mole times 2. And if we plug all this on the calculator, we're supposed to get 95.3 grams per mole. Alright, good. So now we have the two essential components into calculating moles. We can now use the formula and plug in these values. So moles is equals to, so therefore moles is equals to mass over molar mass. So what is our mass? 38.2 grams. And what is our molar mass is 95.3 grams per mole. Again, use your units to help you guide you through the calculations. So we have grams cancelling out with grams, leaving us with moles alone. And if we plug this on our calculator, the answer will be 0.401 moles. All right, so that's the answer for the first question. The second question, what mass of calcium nitrate is present in 0.030 mole of calcium nitrate? So this question is asking us about the mass, and moles are given, and we have atomic values to calculate the molar mass of calcium nitrate. All right, so you write down what you have, and we write this in chronological order. Right, yes, it's important to write these things in chronological order so you will see what you're doing. You will see your units, right, and how everything falls into place. So the mass is given to us is, no, we won the mass, but the moles is given to us. The moles is 0.030, right? And we could find the molar mass by using the atomic values, right? So nitrogen is 14.0 grams per mole times how many nitrogen atoms in this compound? We have 2, right? Plus oxygen, which is 16.0 grams per mole. So there is 3. Okay, so let's make this more mathematically aligned. So let's deal with calcium first. Calcium is 40 grams per mole times 1 plus, since we have both nitrogen and oxygen in brackets and both of them need to be multiplied by 2, so we'll have 2 outside the brackets of nitrogen, which is 14.0 grams per mole, plus oxygen, which is 16.0 grams per mole times 3. All right, so with that, your answer will eventually become 164 grams per mole. So now that we have found the molar mass of calcium nitrate, right, we have the moles, we could then go on and calculate the number of mass. Right, so mass is equals to the number of moles times your molar mass. So the number of moles is 0.030, right, times 164 grams per mole. Then your answer will become 4.3, not 3, 4.92 grams. Okay, so the third question, calculate the maximum mass of iron formed when 798 grams of iron oxide is reduced by excess carbon monoxide. Assume 100% conversion of iron oxide to iron. So this question is a bit different from the previous two that we did, right? But it is same theory, rules apply. In terms of finding the number of moles and those kind of stuff. So what this is saying is that we want to find how many, right? How many iron is formed from iron oxide, right? When reacted with excess carbon monoxide. So the first thing we need to do is to write a balanced chemical equation for this reaction. So iron 3 oxide, which is Fe2O3, reacted with carbon monoxide to produce, I think I write this to produce iron solid plus CO2 gas, right? Iron oxide is in a solid state, carbon monoxide in its gas state. So we add a 3 here and a 2 there, and then a 3, and then this equation will be balanced. Good. So now that we have written our balanced chemical equation, then we could proceed by calculating the number of moles, right? How do we calculate the number of moles of iron oxide? So we know the amount of mass, right? Because the amount of mass is how many? 798 grams. And we could find the molar mass because we already have the chemical formula of iron oxide. So, and they have given us the AR values or the atomic values to calculate this. So the molar mass is going to equal Fe, which is 55.8 grams per mole, times 2 plus oxygen 16.0 grams per mole times 3, right? And then your molar mass is going to be 159.6 grams per mole. So now we have the molar mass, we have a mass, we could actually calculate the number of moles. So moles is going to equal, number of moles is going to equal the mass, which is 798 grams, over the molar mass, 159.6 grams per mole. Grams cancel with grams, leaving you with 5.0 moles. So it's not done yet. That is just the amount of moles of iron oxide. But what they want, right, what they're asking for is the maximum mass of iron, right? So from this information or from this data, we know we could then use the balanced chemical equation to find how many moles of iron formed, right? So it is 1 mole of iron oxide. If you look, 1 mole of iron oxide forms 2 moles of iron. So basic maths, it's a 1 to 2 ratio, right? So if we're going to find the amount of moles of iron formed, it's going to be 5.0 moles times 2 will equals 10.0 moles, right? So now we know how many moles of iron formed. Then we could proceed to say that, therefore, since 10 moles of iron formed, we could multiply it by the amount of mass, right? The amount of mass of iron. So the amount of mass of iron was given in the AR values, which was 55.8. So 55.8 grams per mole, right? If we multiply that, we should able to have, or should able to know, what is the maximum mass of iron formed, right? And that will be 558 grams of iron, right? So moving on to the fourth question, right? So the fourth question, calculate the minimum mass of carbon needed to react with 6.6 to 2.1 grams of lead oxide to form lead. Assume 100% of conversion of lead oxide to lead. Good. This is similar to the previous question that we did, right? But however, the similar question asks for the maximum mass. But this time, they want the minimum mass. All right. So we're gonna take the same approach that we took in the previous question. First, we have to write the balanced chemical equation when lead oxide react with carbon to form lead and carbon monoxide. So lead oxide, which is It's important to put in your states when calculating these, when writing these balanced chemical equations. Good. So now we have the balanced chemical equation of the reaction of lead oxide reacting with carbon to form lead and carbon monoxide. So then we could proceed to finding the number of moles of lead. So we have the grams, or we have the mass of lead oxide, and we could find the molar mass of lead oxide and to find the number of moles of lead. So yeah, after we have our balanced chemical equation, then we could proceed to find the number of moles of lead. So we already know they're already giving us the mass, right, of, which is 62.1 grams, and the molar mass of lead is 207, right? It is stated in the AR value. So now that will equals to 0.300 moles. All right. So the reason why we do this is because remember in the question it asks, they want to know the mass of carbon which react with 6.62.1 grams of lead oxide to form lead. So we have to know how many moles of lead formed, and now we know 0.300 moles of lead formed. Then we could use from this balanced chemical equation to find the mole ratio of between lead and carbon. So here we have a 4:3 ratio rather, right? And because we have this 4:3 ratio, in order to define how many moles of carbon there is, we have to find how much 1 mole of lead form. And how we do this is basically we take the 3 and we divide it into the 0.300, and we'll end up with 0.100, and then we take that and we multiply by 4 to find how many moles of carbon form. So that means it's going to be 0.400 moles of carbon, right? So we find for 1 mole first, and then we find for 4 moles of carbon. Right? So now we know how much moles of carbon form. We could take that number of moles and multiply by the mass of carbon to find how many react in all. Right? So 0.400 moles times the mass of carbon, which is 12.0 grams, equals to 4.80 grams of carbon. And lastly, for the last question 5, 4.60 grams of sodium reacts with 3.52 grams of sulfur to form sodium sulfide, which is Na2S. Which reactant is in excess and how many grams remain? Right? So this question has 2 parts. One, I want to know which reaction is in excess and how many grams remain. So in order to answer or to approach questions like this, we could use mole calculation to know which reactant is in excess. How we do this is firstly by finding the number of moles of each reactant. So the number of mole of sodium is going to equal mass, which is 4.60, divided by the atomic value, which is 23.0 grams per mole. Then that will be 0.200 moles. All right, and we do the same for sulfur. The mass of sulfur is 3.52 grams divided by 32.0 grams per mole, and then we find it's 0.110 moles. So now we have found the amount of moles for the individual atoms. Then we write the equation and determine the ratio of the reacted moles. All right, so we write the equation to know which moles is reacting. Right, so it's basically both of them is reacting with one another to form sodium sulfide. So we write in the balanced chemical equation, and then we take in the mole ratio from that balanced chemical equation. So this balanced chemical equation is going to be 2Na, right, plus S, 2Na solid, plus sulfur solid will give you Na2S, which is, right? So from this equation, we could see 2 moles, let's write this in a different color, 2 moles of sodium react with 1 mole of sulfur. So since the ratio is 2 to 1 and sodium has more moles than sulfur, so for sulfur to react completely with sodium, it basically just need half the amount of moles sodium have, which is 0.200 moles times a half, which will give you 0.100 moles. So sulfur only needs 0.100 moles to react completely with sodium, but we have calculated that we have 0.110 moles of sulfur. So that means sulfur is the element, or sulfur is the atom that is in excess, and by how much we basically calculate, or we subtract the two. So it is 0.110 mole minus 0.100 moles. So sulfur is in excess by 0.010 moles. Alright, so the question also want to know how many grams remaining. So now that we find out which reactant is in excess, how many grams remain is to take the excess and multiply it by the amount of mass of sulfur. So the mass of sulfur is going to equal to 0. It's going to equal to the mole of sulfur times the mass of sulfur. And that's going to equal to 0.010 times 32.0. This is going to equal to 0.320 grams. So now we complete the question by knowing that sulfur is the element that reacted in excess, and the amount of grams that reacted in excess, or the amount of gram that remains, is 0.320. So that brings us to the end of this part 3 of the calculation of mole concept. I hope you find it useful. Key tips to leave with you is that, practice using your units. Your units is very important when it's calculating mole concept, or any calculation in chemistry rather. It'll help you to make sense of your work, or make sense of your calculations. um, Set up your work in chronological order to see what you're about, see the steps that you're taking. So even if that you may have made a mistake, all right, you could revisit your work to see the mistakes or see the loopholes in your calculations. And practice a lot. Practice, the old saying, practice make perfect. Practice a lot, get acquainted with these formulas, so you will know how to approach questions like this, or more challenging questions governing the mole concept. Right, so if you find this video helpful, that brings us to the end. Leave a like, subscribe to see more videos on me explaining complex topics in a simpler way that you could understand. Right, if you need any help in chemistry, I tutor chemistry online. um my number is on the flyer on the screen. You could message me, because it's at my best interest to see you guys um succeed in your exams. Thank you for watching. Leave a like, subscribe, and see you soon.